good morning and good evening and good afternoon where you are. So thanks for joining with us. So it's our honor and pleasure actually to host our today's speaker, Dr. Anna Godinho, madam. So she is currently working as a head of education, communication and outreach CERN, Geneva, Switzerland. And she will talk on communicating the intangible public engagement in particle physics at CERN. So very exciting topic. I think you will enjoy it. And our madam already connected with us. So I'd like to welcome our speaker. So madam, good afternoon to your part and good evening to here. So thanks for accepting our invitation. So I think it's a very good opportunity for our student and the viewers who can directly interact with and who can ask you directly. So madam, it's your time. You can start your session.
Thank you very much for that introduction. Good evening to you. It's afternoon here in Geneva. It's a real pleasure to be here with you today and to be able to tell you a little bit about what we do at CERN to engage different audiences in the research that we do. So this is not going to be a physics talk, physics seminar, unlike the others that you've had. I am actually not a physicist by training. I am a developmental neurobiologist. I studied the development of the nervous system for my PhD, and I've been working in science communication for almost 20 years now, incredibly. And I want to tell you about the experience of doing communication at CERN, and especially how everyone at CERN can be involved in communicating the research that we do. So please do ask questions, and I'd be happy to take any questions. I wanted to start with a brief introduction of what CERN is. I won't go into too much of the physics that we do at CERN, but rather describing the laboratory. So CERN is the European Laboratory for Particle Physics. This is an aerial view, a Google view of CERN, and here you can see. I think you can see my mouse. This is the lake is Lake Geneva. Geneva, the city of Geneva is here along the banks of the lake. This is the airport. And what you see, this big circle here, is something that you have probably heard about, is the LHC, or the Large Hadron Collider, which is the largest particle accelerator particle collider on Earth. CERN is located on the Franco-Swiss border. This purple line that you see on this line is the border between Switzerland and France. So you can see that most of CERN is actually located in France, with some of it located in Switzerland. And I will go into a little bit more detail on what the accelerator is and these 4 points around the accelerator. At CERN, you may know this already, we study the elementary building blocks of matter, of the visible universe around us. And we also try to understand a little bit, or trying to understand what makes up the invisible universe. So matter, as you know, is made up of atoms made up of nuclei with electron orbitals around. Inside the nuclei, there are protons and neutrons. Inside the protons, we now know protons are made up of quarks, up and down quarks. And as far as we know, these are the so-called elementary particles. We have no indication that quarks are further divisible, can be further divided into smaller particles. And this is the range, so 10 to minus 18 meter. This is the range of particles that we study, invisible and also intangible in a way, which is hence the title of my presentation. As you know, the universe is almost like a Lego game, a self-assembling Lego game, immediately after the Big Bang, so a billionth of a second after the Big Bang. The elementary particles that I mentioned before, so the quarks, also the leptons, electron, neutrinos, would have existed, would have come together to form the protons. At CERN, we also study the interactions between the quarks the strong force that allow them to then come together in the proton. Protons will have come together to form nuclei, atoms formed different heavy elements, molecules that then ultimately gave rise to life. So we are really looking at this stage of this Lego assembly, if you like. Which also means that we're looking back in time. What we're doing at CERN by studying the elementary particles, the building blocks of matter of the visible universe, we're also looking back at these the first moments, so the billionth of a second up to 380,000 years after the Big Bang, when these elementary particles existed. So in a way, particle physics is at the other extreme of astronomy and astrophysics, whereby we use telescopes or radio telescopes to look back at how the universe was formed, but existing current telescopes cannot look beyond 380,000 years after the Big Bang. And this is where particle physics, accelerator-based particle physics comes in, because we can reproduce the conditions immediately after the Big Bang. And we do this by colliding particles. When two particles collide in a process that is described by probably the most famous scientific equation on Earth, Einstein's E equals mc squared, the energy of the collision is converted into mass, the mass of potentially new particles or different particles. And this is the process that underlies the equipment or our approach at the research we do at CERN. And I come back now to that first image. So this large ring is 27 kilometers in circumference, in length. It is about 100 to 150 meters underground, and it is, as I said, the largest particle accelerator on Earth. It's the LHC. It is one and the flagship accelerator at CERN, but you will see smaller circles represented here, and these are smaller accelerators that are used to increase the energy in different steps, increase the energy of the particles until they enter the LHC, where for most of the year, protons will circulate at a speed of 99.999999% the speed of light at an energy of very close to 14 TeV. These particles will collide. And they collide because it is a collision that gives rise to the data that we analyze, that gives our research results. And they collide at 4 points around this ring where giant detectors have been built. And these detectors have the following names. There's ATLAS, ALICE detector, CMS detector, and LHCb. ATLAS and CMS, are general purpose detectors to study the Higgs boson and other aspects of particle physics. They're very similar in the questions that they address, but very different in how they are in their structure and what they look like. LHCb is a detector that is looking into this also very interesting and very deep question of the difference between matter and antimatter, to explain why it is that we live in a universe of matter, what happened to the antimatter. And Alice is looking at the very first moments after the Big Bang, before quark and gluon, when the quark-gluon plasma existed, when the universe was made up of quark-gluon plasma. And this is always achieved by colliding the particles. Now, you may have heard of the Higgs boson. Through accelerator-based research over the past 60 years, the particles that make up what we call the standard model of particle physics, which is probably the strongest and most solid model, scientific model across all fields, has been, the particles that make up this model have been discovered. The standard model is it's often described as the periodic table of particle physics. It describes the elementary particles known to date, namely and in the families of quarks, the leptons, and the forces that govern the interaction between those particles. There was a particle that was missing that had been that was theorized, that had been proposed by theorists in the 1960s, in 1964, and this became known as the Higgs Higgs boson, and this was a particle, unlike all the other particles that are vectorial. This is a scalar particle, so it has the same dimensions, the same properties in all dimensions and on all axes. This was the missing piece of the standard model, and in 2012, so 10 years ago now, the Higgs boson was discovered at CERN by two of those detectors that I mentioned earlier, two of those experiments, ATLAS and CMS. Independently, the results were then compared and confirmed that what they had identified was the Higgs boson. Now, Higgs boson, quarks, leptons, gluons, all these, the building blocks of matter. These are some of the most fundamental questions, fundamental scientific questions asked. So particle physics really is the most fundamental research fields. From someone coming from the biological sciences, where there is fundamental research, but certainly nothing more fundamental than that understanding the elements, the building blocks that make up matter. Now, despite all this, because you would think that because the questions that we're asking at CERN are so fundamental, there is no direct application in technology, in industry, in daily life for the Higgs boson, for example. Yet there is an enormous interest in CERN from the media, from the general public, and I will show you. This is, for example, is a plot of the number of media clippings from 2012, when the seminar announcing that the Higgs boson, or what seemed to be a Higgs boson, had been discovered at CERN. The number of media clippings over the years until for the following year. And you will see there's a huge number of media clippings. And really, I was not at CERN at the time, but my colleagues have told me that CERN was inundated with journalists from all over the world wanting to sit in on a scientific seminar to hear the announcement or not of this particle, of this wonderful particle, of this very basic, very fundamental particle. In 2019, jumping few years, and I've chosen 2019 because with the pandemic, these numbers have changed because CERN has been closed to visitors for most of the time. But in 2019, 150,000 people from 95 countries came to CERN and took part in the guided tours that we organized for our visitors. We held the open days over a weekend in 2019, and almost 75,000 people visited the lab over those 2 days. Every year we have close to 1,000 teachers from over 50 countries that come and take part in the programs. We have a hands-on physics laboratory for high school students and also the general public, and more than 6,000 high school students come to School Lab every year. Media interest in CERN continues. We have more than 156,000 media clippings per year on average, and many journalists want to visit CERN. We have a large following on social media too, and I'll go into that in a little bit of detail. So despite being a laboratory for fundamental research, and many people not really understanding what the Higgs boson is or why it matters, we have all this interest. So why is there this interest in CERN and in particle physics? And basically it's because we have amazing stories to tell. And science communication is all about telling good stories, and we have the best stories. We have stories about the big questions that we ask at CERN. So these, trying to understand the building blocks of matter, the building blocks of the visible universe, really ties into some of the questions that have been, if you like, plaguing humanity for millennia. These are the questions that philosophers asked, and were, until experimental science came to the fore, really in the realm of philosophy. And these are questions of where do we come from? What is it that we are made of? How have we got here? How has the universe evolved to where we are now? How do humans exist? What are we made of? Where are we going? If we understand our history or evolution of the universe, we can also gain some understanding and make some predictions about how it will evolve in the future. So these are big questions. These are wondrous questions. And wonderful questions. Wonder is one of the intrinsic characteristics of humans. And then we have everything about CERN is a superlative. We have stories about the world's largest particle accelerator, the LHC. It is big. It is cold. It is and it's empty. It's in the vacuum, or the tubes in which these tubes represented here, in which the particles circulate, are under extreme vacuum. So we usually say it's the fastest racetrack on the Earth. It's one of the coldest places in the universe, and it is one of the emptiest places in the universe too. The detectors themselves, those 4 detectors that I mentioned, and other detectors at CERN, are some of the largest and most sophisticated instruments ever built by scientists, and they have been built and placed 150 meters underground. This is a picture of one of the detectors, the CMS detector. Here you can see the beam pipe. This is a pipe through which the particles circulate, and there is a person. So you can see the scale of the detectors. These detectors, with each collision, there are approximately 1 billion collisions per second, and only approximately 10% of those collisions are recorded as data that then is analyzed to find out, to understand, to follow the mass, or rather the momentum, the charge, and the momentum and the charge of the particles. All this data generates exabytes. So all these collisions generate exabytes of data that are stored in data center at CERN, but also data centers spread around the world that are connected, and to which physicists from all around the world connect to obtain the data and analyze it. But we also have stories about the impact of CERN on society. So this is a picture of Tim Berners-Lee. You may know Tim Berners-Lee was the inventor of the World Wide Web that we all use today. We're using now. That has really revolutionized society. And Tim Berners-Lee was a scientist at CERN when he invented what then became the World Wide Web, and it was invented as a system to allow different computers around CERN to communicate with each other. And boy, how it has grown. And core to the values of CERN as well is that the web was made available to the world, to everyone, for free. That is core, that everything that is done at CERN is available in open source. But CERN CERN trains many scientists and engineers for the future. It drives innovation. Many of the technologies used at CERN have found applications in other areas, namely in medical imaging, and even in treatments. So there are cancer treatments that are not based on X-ray, but on hadron therapy, so on accelerating beams of hadrons rather than beams of X-rays. This is based on technology that was developed for accelerators, including at CERN. We have human stories to tell, because behind all these incredible machines, incredible equipment, these cathedrals of technology and these applications are people that come from more than 100 nationalities that work at CERN. We're not always all at CERN. So the 17,000 that are mentioned on this slide, of them in normal years, about 9,000 are on site on average any one day. And then but we have many physicists that are in their institutes around the world and connect to CERN. It's also a story about the values. We also have stories about the values of CERN. CERN is an international organization made up of 23 member states and 6 associate member states, but available to physicists and engineers all around the world. And CERN, as we use a slogan at CERN, which is science for peace. So this is a place where people from different nationalities, different cultures, very often from countries that do not recognize each other politically, that may even be at war with each other. Scientists, there are no barriers here. Scientists come together for a common cause, which is to understand what makes the universe around us. This is a picture of our Director General, Fabiola Gianotti, the first woman Director General of CERN. Now, we have all these stories to tell, and we will continue to have good stories to tell, because there are many questions in fundamental physics, in particle physics, about the universe that we don't know the answers for. We don't understand what makes up 90%, 95% of the mass and the energy of the universe. We only know what makes up 5% of the mass and the energy of the universe around us. As I said earlier, why is the universe made of matter? What happened to the antimatter? Is there only one Higgs boson? Does it behave exactly as we expected, as we have been investigating over the past 10 years? Gravity is not represented in the standard model of particle physics. Is there another model that can be built that will bring gravity into it? Why is gravity so different from the other forces that are represented in the standard model? These are all questions that we are investigating, and these are questions that the community as a whole around the world, but using CERN as a basis, is already trying to address, and is already proposing to address via potentially a bigger collider, bigger than the LHC. So if the blue ring is the LHC, there is a proposal that is now under study, so it has not been approved, to build an even bigger collider of 100 kilometers in circumference. And why a bigger circumference? Because this will allow higher energies to be achieved, and therefore increases the discovery potential. So these are very exciting times for CERN and for the field. So we will continue to have good stories to tell. So why do we communicate? Why is it important, and why do we enjoy communicating? We communicate to engage key stakeholders with the research, the world-class research that CERN carries out. And this will help us to ensure sustained support for the lab's scientific goals. These stakeholders are decision makers, so politicians, but also the media and the general public, teachers, students. We communicate because we want to increase the visibility of CERN's member and associate member states. CERN, we often say that CERN is their national lab at an international level. We are what the member states and associate member states and the scientists from more than 100 countries who come to CERN. CERN is made by all of those. We want also to contribute to generate awareness and engage the citizens with the societal benefits of CERN. Although we carry out the most fundamental research there is, the technologies that we develop to answer our questions find applications elsewhere. So we want to tell those stories. This is how, again, it speaks to the value of fundamental research. And that is also what we communicate, to establish CERN as a leading voice for science, a leading voice for fundamental research. And we want the citizens all over the world to engage in the values of science, openness, sharing, but also the process of science. So critical thinking, critical reasoning, discussion, debate. Who do we communicate with? So we've tried to break down our audiences into primary audiences. So these are the audiences who either have a high interest in CERN and or have a larger power to influence the future of CERN. So clearly decision makers, governments, ministries, funding agencies. The particle physics community, the community that uses CERN, especially as we're looking forward, as we're making plans for the future. The wider scientific community, other scientists outside particle physics who are in other research areas, and that that can look to particle physics and to CERN as a model for large collaborations. The local communities, our neighbors, you will have seen that ring goes through communities, goes through small villages and under people's homes. It's important that our neighbors understand and engage with what we do. The general public, so those further away, whether they are already interested in CERN, whether they're not interested in CERN, or whether they're neutral about CERN. Teachers and students. Teachers are a fundamental audience. They are great multipliers. One teacher that comes to CERN or that interacts with CERN can potentially reach 30, 60 more students. Students as well are key target audience. These are the scientists, the engineers of the future. Industry is also a key target audience, especially again as we're looking forward. We're looking to build a future collider. It's important that we have industry as partners in developing the new technologies, and clearly also internal communication. Our community, to build a spirit of community within CERN. We also communicate with the media. We see them as vectors. The media are not a target audience in themselves, but they're vectors to reach other audiences and influences, whether they be social media influences or flesh and bones influences, if you like. And the alumni, those who have been through CERN and now elsewhere, spread around the world and can become real ambassadors for CERN. Now, how do we communicate? What underpins everything we do when we communicate and when we reach out and when we carry out our education programs? We communicate with transparency. We are very open about what we do at CERN. We try in as much as we can to know our audiences. So we don't communicate to our audiences, we communicate with them. We balance the local and the global. So CERN is implanted here in this area, so we obviously have to communicate and engage with, and we enjoy engaging with our neighbors, but we are also an international organization, so we also engage and communicate with our member states, with our associate member states. And we don't do it alone. We couldn't do it alone. We do it through partnerships, whether they be local, regional, national, or global partnerships. And anyone at CERN can take part in this communication, and we really encourage everyone at CERN, whether they be engineers, physicists, technicians, working more in the administrative fields. We encourage everyone to take part in the many activities, the many communication activities that we put in place. And this is very rewarding for the lab, but it's also very rewarding on an individual level. If any of you have ever done any science communication, you will know how rewarding it is. It allows you to share the passion that you have for science and research. By communicating, you're also contributing to increase the citizens' science literacy, have a greater understanding of science, of the values of science, the impact of science in our society. It gives you transferable skills. You learn to communicate, you learn project management, you learn storytelling. These are all skills that are very useful, even if you decide to leave science. It gives you, and there is research, there are studies that show this, it gives scientists a different perspective on research, because the public, the general public, the non-scientists, and even scientists in other fields will ask you questions that your peers, your colleagues will not ask you. And it helps you to look at, it can often lead you to look at what you're doing in a different angle. And it can be very good for career prospects, even in your scientific career, to show that you have science communication experience, or, as I said, if you at some point in your life, like I did, decide to change career. Let's start with social media. So CERN is present on the main social media channels. The first one the lab joined, was Twitter in 2008. And this table here, or this block, shows you the number of followers we have on each of the social media channels, and clearly we adapt our communication to each of the channels. And here there are many ways of taking part in communicating by social media. And please, I invite you all to follow CERN on your favorite social media channels. Be a digital ambassador, speak, be a voice for CERN, for particle physics. And if you are at CERN, share the stories with us so that we can share them on our social media channels. We are just coming out of a period at CERN that we call long shutdown. This is a period where the accelerators and the detectors are stopped, so they have not been running, and this happens every 5 to 6 years, and it's long shutdown because it goes over a period of 2. This one is a little bit longer because of COVID, 2 to 3 years, and this is a period where major repairs and maintenance work is done on the accelerators and the detectors. Now, very often there might be a perception that so if the accelerators aren't running, that means you're not doing anything at CERN, but actually a lot is happening. And we use social media through lives. We've done several lives from different parts of the accelerator and from different detectors, showing the work that is ongoing. This is also the period where there is very strong data analysis, where the physicists are sitting at home or in their offices crunching the data and writing papers. Here too, we rely very much on the CERN community for these lives, because we try to make them as interactive as possible. First, we record them, we broadcast them from the actual locations, so not from offices, but from actually underground, from the facilities. And we also we promote interaction, so there are online Q&As, and so we need experts with the social media team that can answer the questions that come in. We juggle our social media between regular content. So we have these regular features. We have a photo of the week every Wednesday. We have Throwback Thursday every Thursday, clearly. And then we have a Guess What It Is, where we put up an image on a Friday, ask people to guess what it is, and then give the answer on the Monday. This draws a lot of engagement, and we're using these now as well to develop specific campaigns. And the latest campaign that we developed was the Women and Girls in Science. So 11th of February, just past last Friday, is the International Day of Women and Girls in Science. And so we had many stories of women physicists, engineers, working at CERN on our different social media channels. And coming now in 2022, we will have the restart of the LHC. It will start around April. The first physics, or the first high energy collisions that give data that physicists can use that are considered results physics. And then in July 2022, we will be celebrating the 10th anniversary of the discovery of the Higgs boson. So follow us on social media. Stay tuned, because there will be more and more activity around these three campaigns. The media are a key vector for our communication. So we have a very strong press team at CERN that carry out all our media relations, establishing the relationship with journalists from all around the world. We put out press releases. We organize visits of journalists on site. Now during COVID, we have set up online visits. We organize media training. So one way if you're at CERN or associated to CERN to take part is to be interviewed, for example. So we offer media training so that you are prepared to be interviewed by the media. And here the way of taking part is to share stories with us, do the media training, become an ambassador. Digital is great, and especially over the past 2 years, we have relied so much on digital. Nothing beats face-to-face in most circumstances. So we very much believe in the power of face-to-face. And here we have our guided tours. So we have on an average day, in a normal year, we have around 150,000 visitors that come to CERN, but we have many more requests that we're not able to satisfy. We organize regular public events, the open days that I mentioned earlier, and others. We also go out into the community. So we're not just sitting here and waiting and inviting people in. We also go out into the community, into the local schools, into local events. We have the workshop that I'll mention, and the teacher programs that we run. So the guided tours, all this, we need volunteers, and we'll need more and more volunteers. So everyone at CERN is encouraged to become a guide, to volunteer for these events. 60% of the visitors that come on CERN's guided tours come from more than 600 kilometers away. So people travel very far to come to CERN. And also 60% are schools that visit CERN. This is a picture from the open days, and this pie chart just shows you distribution of the ages of those who visited us. So people from all age, many families. And here too, we relied on volunteers. We had 2,800 volunteers for that weekend of the open days. The teachers, as I said, close to 1,000 teachers come and spend 1 or 2 weeks at CERN, professional development programs. We run programs for high school students, covering students of CERN's member states, who are now reviewing and thinking of how to change our high school students' internship programs. This is a picture of the school lab, so the hands-on, minds-on particle physics laboratory, where students, teachers, and the general public can explore their inner scientists, we say. We've been hit by COVID as well. 2020, 2021, 2022, we're hoping things will change in 2022, were years of COVID, cancellations, but also many years of creativity and change. We clearly had to cancel many guided tours. the on-site teacher programs, School Lab also closed, and we haven't had many events on site. But we went online. We created a section on the website, on our website, to discover CERN online. We've set up virtual tours and talks. So it is still possible to visit CERN virtually from wherever you are. Our education team that runs School Lab also went online and produced short videos that were posted on our social media channels, and that have really were very well received across social media. So these are short videos of hands-on experiments that you can do at hands-on physics experiments that you can do at home. We've also, in the meantime, set up science shows online too. Now that things are easing up, we have people in our the place is called the Globe, to see the science shows in person, but they're also broadcast online to reach further. We have an arts program at CERN called Arts at CERN, where artists from all around the world are selected and come and spend some time at CERN and develop their ideas. And this is a picture of an exhibition in the Victoria and Albert Museum in London. It's an exhibition around the work of around the book Alice in Wonderland, and this is an installation by one of the artists in residence at CERN. So again, this is a way of, through art, communicating what we do at CERN, what science is. And then there's another event that we've started last year, which we've called Sparks, the Serendipity Forum. And this is really, the goal here is to really build on this spirit of openness and international collaboration of CERN, and establish CERN as the place to have conversations that wouldn't happen anywhere else. So last year we had the first edition of Sparks, and it was on the theme of artificial intelligence. So here at CERN, we use machine learning and artificial intelligence to some extent. So we brought together experts from science, but also from ethics, from psychology, from the political area, to talk about where we are with AI, what the future could bring, what we need to think about now in preparing a future with AI. This was last year in September. We produced a series of podcasts, and all the talks are also available online on the website. The link is here, and we're preparing the second edition for the end of this year, and this one will be on future technology for health. So we're looking at what health in the future is going to look like, and the impact that technologies today, again AI, but other technologies can have on health as an individual and as a society. And then finally, our new project to go even wider and even bigger in everything that we do for communicating and engaging in CERN and in science is the CERN Science Gateway. So this is a new education and outreach facility. This is an artist representation of part of the building. It is being designed by the Italian architect Renzo Piano, that has designed other works such as the Shard in London, the Georges Pompidou Center in Paris, and other very famous buildings. We want to reach younger audiences. Currently, our programs are targeted more at secondary schools, so 14 plus. We want to reach younger audiences from 5 onwards. This Science Gateway will have exhibitions, immersive exhibitions that recreate CERN and recreate the research that is done at CERN. We will have education labs, and it will also be a place where we will host our events and our science shows. It is under construction, and we're hoping to open in summer of next year. And here again, we've had many contributions from physicists, engineers, technicians all around CERN for the exhibitions, for the programs that we're putting in place. And we will also be really relying on volunteers to be on the exhibition floors, to be tutors in the education labs, to be present in our public engagement events. And I will end here. This is a an aerial view taken by a drone of CERN. It gives you an idea of one of the campuses of CERN on the Mayhan site. You have my emails. Please feel free to get in touch, and I'm very happy to take any questions you may have now.
Okay, madam, thank you for a wonderful presentation. So we don't don't even get any question yet. So thanks again. So as the video will stay remain in Facebook and YouTube, so I think they may ask a question later, and
Absolutely.
I think we can send those questions to you if I'll get those questions. So thanks again, madam, for giving us this opportunity. It's a very great lecture, general lecture. I think the student, not only physics student, but also student of science also can find some interest in this lecture. So
I hope
thanks
so.
again. Bye for today.
Okay. Bye-bye.
Bye.